Can you just let's go outside, then just on your, if you can hear us. Just let's go outside, then just on your, if you can. Hello, hello. Okay, I think it should be fine. Hello, hello. Good morning, everyone. Thank you for coming. We'll be starting shortly. Just give us 2 minutes. Okay, sorry for the inconvenience. We just had a small delay, but nevertheless, I think let's get on with it. Good morning, ladies and gentlemen. Thank you for coming to the second day of our NUST-DARA Data Science School. It's really a pleasure to see you again. I know the participants, some of them might still be on the way because yesterday we were bombarding them with a lot of Greek and a lot of codes, and I'm sure some of them were even up late just trying to digest some of the things that we were talking about yesterday. It's today, basically, I don't even know how we planned it or how we organized it, but after realizing looking at the program again on hindsight, actually realized that the first day was academic and today is industry, and it was not planned. It just happened by coincidence. I don't know if it was unconsciously planned, maybe. I'm looking at the bosses because they are always the one advising on, on the programs that this and this must go there. And it's really good to have our acting Deputy Vice Chancellor for Research, Innovation and Partnerships here, Dr. Colin Stanley, and also to have our acting Dean in the Faculty of Computing and Informatics. And really, it's also a pleasure to have Carla Sharp, who is the Africa Program Manager at the South Africa Radio Astronomy Observatory, Sarau, who flew in from Cape Town yesterday just to come talk to us. And thank you very much, Carla, for really setting our invitation to come here. Really we're looking forward to hearing from you today. And also, would like to also then also appreciate our speakers for today. We have Carlton Peterson, who is a data scientist and RPA developer from Standard Bank. And we have very, very important partners who are with us always, MTC. So we have Ms. Fidelia Ndapopile and Mr. Elashimi from MTC, who will actually be also discussing how they actually leveraging or using data science in the industry. And really, academics have changed. It's no longer the traditional way of how we have known academics. It's really about partnerships and close collaborations with industry. And we really appreciate to have industry working together with us. Because we, the academics, will come up with these novel techniques, but we need our industry partners to then take these techniques to the market. And we really appreciate these partnerships. Again, welcome to the second day of the NUST-DARA Data Science School. It's really good to see everyone here. And of course, we also welcome people who are actually joining us and following the discussion from the NUST YouTube channel. We appreciate it. And yesterday we've been getting a lot of nice feedback. And that actually just shows how people are interested about these kind of discussions around data science, which is really good to see. And it also just shows the university leadership that this is something that as a university should take, and I'm sure looking at my boss, to make sure that we kind of ensure that we satisfy this hunger and this desire for reskilling and upskilling around data science. Without further ado, and without wasting too much time, I'm a lecturer, so I speak a lot, and I think it comes with a job. But for today's proceedings, we're going to have remarks from our acting Deputy Vice Chancellor for Research, Innovation and Partnership, and then we're then going to have a keynote talk from Carla Sharp, who is then going to talk to us about what is the SKA and what it means for Africa, and how you as Namibian inspiring data scientists can participate in this massive or the biggest science project currently. And then after that, we're then gonna have a talk from our industry partners, from Mr. Charlton Peterson, and then a talk on data science and the experience of MTC from Ms. Fidelia. And then we're then gonna have both of things from our amazing acting executive team. So let's now start the proceedings for today. I would like to actually, it's my pleasure to welcome our acting Deputy Vice Chancellor for Research and Innovation, Dr. Colin Stanley, to just give his remarks. Dr. Colin, a round of applause for you, please.
Good morning, how are you? I know today is not that bad as yesterday, but they say never underestimate who's the audience, who's in the audience, who's there sitting there. We could have our coming president or the new Bill Gates sitting here today. It is my distinct honor to provide welcoming remarks. Dr. Carla Chap, Africa Program Manager, South Africa Radio Astronomy Observatory, SAR, AO, and also our esteemed invited speakers. I believe there's also speakers online, right? Yeah, so also welcome. And we have also one of our speakers today. We have Mr. Charlton Peterson, data scientist. And you see on the program, his abbreviation is RPA developer. Now, RPA developer is robotic process automation. So that's quite interesting. We'd like to hear from them, from Standard Bank. And then also we have Ms. Fedria Popele, data engineer from MTC, and also Mr. Ella Shimi, a data scientist also from MTC. Are those colleagues here? Ms. Ella. Oh, sorry, apologies. And ladies and gentlemen, once again, good morning. It gives me great pleasure to be with you this morning on this second day of the NUST-DARA Development in Africa Work Radio Astronomy Data Science School at HTTPS NUST. Now, HTTPS today, the director's ceremonies had mentioned that is for industry partnerships. And HTTPS was actually launched with that strategic thinking. It's not your hypertext transfer protocol secure, it is high-tech transfer plus a select, really the select to select strategic partners to bring the industry into the academia. This is actually one of the first science parks in Namibia, really for us to work on open innovation of other industry partners that will be housed at this very beautiful building. We all know this phrase, data is the new gold mine, it's the new fuel, the most valuable asset of any modern society. So we hear quite often this, and I think it is a statement that is just said, that is not just said. This is not a political statement, it is a reality. However, raw data in its natural form is not beneficial. I know sometimes in their colleagues from MTC, you hear sometimes the user says, my data is finished, I need to buy data. Do we really know what we are saying when we say that? Just pause for a minute and think about that. Yeah, so additionally, today organizations in the private and public sectors want to leverage on data to enhance decision making. Data science is a necessary discipline. It is often regarded as foundation for many sectors in the digital economy. 4 years ago, there was an article in Brainstorm magazine where they indicated that King Shaka Zulu must have been one of the earliest data scientists. And actually, they worked on the rationale that data science will study our past events, patterns, to make well-informed decisions. And he exactly did that. He noticed that his warriors, the shields were too big, and then the spears was too long. So he modified this to have better fighting techniques. So you can see this is not a new concept. So therefore, there is, though the fourth industrial revolution aimed at making business more efficient by increasing productivity, this revolution concerns all of us, especially the fourth industrial. It's not only for industries. So therefore, there is a need for capacity building, reskilling, and upskilling initiatives. And initiatives such as this one, the NUST-DARA Data Science School, are essential for developing those rare skills for both AI and beyond. There was recently also, if you look at all the demanding skills that are needed, data science is in the top, not only in demands of need, but also in terms of highly paid specialization. And looking at the problems that we're going to solve, part of this hackathon, one of it is fact prediction. And I think if you look at the news few weeks ago, you know what happened in our sister country. And you know problems that we solve can save lives. And yesterday there was a talk on how we can use data science or classification to really predict drought. Imagine that for farmers, just by observing from the sky and also observing what is on the ground, on the grass. And then we using the weather and what is on the ground, on the plantation, we can predict that we're going to have drought. I mean, that is better planning for the government. Say, okay, it looks like over 2 years or 1 year there should be drought. Let's plan in advance. We are going to do image classification and sedimental analysis. So I'm pleased to really see the solutions that you will come up with. You know, initiatives like this is where we spark innovation. This is the ecosystem for us to develop new products that have never been seen before. So I wish you fruitful engagement. So enjoy it, make the best out of it. Thank you.
Thank you very much, Dr. Colin Stanley, our DVC for Research Innovation and Partnership. And he's an adamant innovator, always looking for stuff. And for those that do not know, Dr. Colin Stanley taught me, and when he taught me, web application development, and every time he was always talking about new ways of doing stuff, and which until today continue to give. And really, thank you so much for the support for these kind of events and initiatives. I think these are the kind of initiatives that will actually allow us as a university to transcend, as you have said, beyond just the ordinary academic essence. And another round of applause for our DVC, please. Okay, so next up, we are going to have our keynote talk for today. And after looking at Carla's bio, which is long and because of her expertise and experience, so there is something that I really like, and this starts with a quote, and it says that technology is a tool we use to convert inspiration into realization. And I'm dedicated to positively impact lives in Africa through space, science, and technology. And for me, after just seeing that, it resonated with me, because I also call myself as a technology activist. And all of us really is, how can we really dedicate our lives to positively use technology to impact people's lives. So Carla, she has been with the South Africa Radio Astronomy Observatory, SARAO, for almost a decade. And she has been part of the international effort with the SK, which is the Square Kilometer Array, to build the world's largest radio telescope, as we have heard yesterday. and she will share more on that today. And she is currently responsible for planning, negotiating, and implementing strategic and funding solutions for Africa program across 8 Africa partner countries, which Namibia is also one of the partner countries. So looking at my bosses again, there's funding there being spoken. So let's see what we can do about the funding aspect. Okay, in 2009, Carla founded the Foundation for Space Development and in 2011, Women in Aerospace Africa. So for women in the room, please engage with her on how you can actually get into some of these programs. The CV is, the bio is very long, but it's very, very insightful. So I'm going to try to make sure that I take as many important stuff out. The telescope, she's also been since 2014 on a project called Africa to Moon, a low-cost solution to performing radio astronomy on the far side of the moon. Wow. It is developed to highlight the potential and the ability of the African community to and to inspire Africa to reach for the moon by reaching for the moon. Semantics. So the telescope will provide scientific insight and, importantly, first-time science. It will be made up of 54 self-inflating radio astronomy balls, each representing a nation in Africa. And as a continent, Africa is here to work on an inclusive multinational space program that enables Africa to highlight our potential and capabilities in science, technology, engineering, and innovation. So she has also completed a degree in finance, economics from the University of Cape Town, and she also graduated with an MBA, and she's actually currently completing a PhD at UCT in the Space Lab. The topic for her research is to reliably determine socio-economic benefits to be gained from public investment into space science, technology programs in developing nations, and sustainable level and nature of investment that will optimize these benefits. Wow. And for me, I think the last part is the most important thing, because we invest millions in the telescope, but what how will it change the socio-economic lives of the people that, especially here in Africa? And looking forward to hear they can actually reading the final thesis once you actually done with it. So without then trying to read what Carla has done or what she's about to do, let's then call Carla herself to come and give us a keynote. Let's give her a round of applause. So, okay, you can stand and then going to.
The need to choose. Okay, good morning. Thank you for having me here, for your time. Lamek made me sound way cooler than I am. Whenever someone reads a bio, you think, wow, really? But I have been with Soraya for the last 10 years in 3 different capacities. I started off as the business development manager, then I managed business operations, and for the last 3 years, I've been managing the Africa program. So I don't know how much you've talked about SKA through your talks yesterday, but I'll go over it quickly just to give you a background. So the SKA is an international governmental organization, so essentially a treaty organization, initially set up by 12 countries around the world. Now we have more partner countries, and the objective is to build the square kilometer array telescope. So square kilometer array, you couldn't build a dish a square kilometer in size. Always technical difficulties. Okay, well, while he's doing that, I can chat. So initially they wanted to build the equivalent of a dish that was a square kilometer in size to be able to do the science we want to do in space, but it's impossible to have a dish that big. So they designed a telescope made up of about 200 dishes, approximately 15 meters each in diameter, and together they can act as the equivalent of a square kilometer dish. That's why it's called the square kilometer array. It's essentially, we are doing the biggest technology project in Africa. And I say technology project because I don't know how much you know about radio astronomy, but radio astronomy is essentially a data project, an engineering project. We've had to develop, which I'll go into more later, but we've had to develop new ways of transporting data, storing data, analyzing data, because we've never dealt with this much data before. The technologies used within the telescope are new and groundbreaking. The correlator, for example, for Meerkat, we have 64 dishes. Each little packet of data that comes in through those dishes has to be time-stamped. So I'll talk about the volumes later, but all of those have to be correlated. We had to design a new computer to be able to do the correlation. So there was a lot of new developments, both in standard engineering, mechanical engineering, electrical engineering, data sciences, all to produce the instrumentation to do radio astronomy. The Meerkat telescope was committed to the project in our bid as South Africa to host the square kilometer array. So we built the Meerkat telescope, and when construction starts, hopefully very soon, on the SKA phase 1, when it's complete, the Meerkat will then be integrated and become part of SKA. Okay, so as South Africa, we originally built the CAT-7 telescope. This was an engineering prototype, 7 dishes in the Karoo, and we just did this as a demonstrator for engineering, but actually it did really good science until Meerkat was built and overtook its capabilities. This is a Meerkat dish. They are about 5 stories high. They're quite awesome to look at when you're standing in front of them. And in 2018, the full 64 dishes were complete, commissioned, and inaugurated. I don't know if you've seen this image, but this was the first image we released from the Meerkat telescope. This is the center of the Milky Way galaxy. If you look at the very bright area in the center, that is the black hole, center of our galaxy. To the left of that is a star nursery. That's where stars are being formed. And if you see to the left of those little bubbles are actually supernova remnants. So that's where stars have exploded and died. So I like to say there's the star nursery and the star graveyard. I think what's important to data scientists is our telescope doesn't look at space, it listens to space. We receive radio waves, and that we receive in the form of data, and that produces, the data scientists produce these images from the raw data. So we don't take pictures like an optical telescope. So these magnificent images are created by specialists like yourselves in data science. So the data pipeline, Meerkats itself requires a data usage 10,000 times that of what we use in our normal home fiber lines. We have, this will scale up to tens of terabits for the SKA phase 1. The dishes generate about 2 terabits per second, so this is equivalent to 5,500 digital TV channels playing at the same time. What's interesting about our correlator is we phase up the data, so at some points in the process of analyzing the data, we scale up to 15 terabits a second, and that is then scaled back down to 2. Meerkat is also an interesting instrument because it's a multi-cast instrument, so it can perform different kinds of science, different science programs at the same time. This allows us to collaborate. So we have another data partnership with Breakthrough Listen. It's an organization in America that's collaborates with SETI. You may have heard of SETI, the Search for Extraterrestrial Intelligence. And so they have high performance computes established at the back end of the telescope, and our data runs through those computers searching for electronic signatures, so non-natural technology signatures. And that's an enormous data program on its own that we collaborate on. What's important is the science products. Yes, we're trying to do groundbreaking science, and we have already discovered some interesting things and hope to discover many more with the SKA. The SKA looks to solve fundamental problems like what is gravity, dark matter, dark energy, origins of life. All of these things our scientists look to solve, but there are many layers that lead to this. The pipeline of PhDs, 170 PhDs and 260 master's degrees have come from our bursaries. We've given over 1,500 bursaries since the start of the program, and nearly 150 of those have been awarded to our Africa partner countries, the 8 countries we partner with. We started this pipeline 10 years before we started construction, because we realized that if we were going to build a telescope, we wanted South Africans and Africans to be operating, maintaining, and doing science with the telescope. So when this project originally began, there was only a handful of radio astronomers, African radio astronomers. Now there are hundreds. So that data pipeline, people pipeline, was really essential to this project. We've partnered, because of our specialities within the project, largely in data science, we've partnered with our South African National Space Agency to help them develop their data cube for remote sensing data, the data from Earth observation satellites. And then, of course, innovation and commercial activities, which I'll come to. So I'd like to talk about the science-driven economy, because this project began with outreach and awareness, educational programs in schools, the beginning of the human capital development. And this I like to refer to, this is part of what I study, the intervention phase. Then we use facilitated development and localization. This is where we supported local industry to partner with us to develop the technologies we didn't have and that we needed. And in some circumstances, we just couldn't afford the technologies out there. So we had to develop our own technologies. We needed our supercomputer that works at the back of the imager, and our tape storage solutions. These require, we couldn't afford what was available, and so on the open market, so we had to develop something new. And we developed the most efficient supercomputer of its kind in Africa, and we did it for 30% of the price of any other supercomputers available. So out of necessity, a lot of innovation happened. And then we moved into an innovation and commercialization stage. I'll touch on those, but there are a number of technologies now that have far-reaching impacts in other sectors, they can be spun out, and we've done this in partnership with the industry. And the cycle grows and grows, and you end up developing economic benefits from science. And so how we do this is in 7 steps: foreign direct investments, even cultural impacts and effects. I mean, we have partnership with the local Sand Council because there's a lot of historical artifacts we rebuild, and we've partnered with them. And in the hopes that our partnerships can help secure and maintain their traditions that are being lost as we move into this modern age. Artists, we have a number of astronomy and space artists that we support. So there are a lot of cultural areas that you can get involved in the science fields, not just pure science. Science products I've discussed, education and industrial spillover, and then of course ITC and data spillover impacts. Just a note, so we have radio astronomers, we have data scientists, we have energy engineers, and we got hit by the COVID pandemic like everybody else. And we took all of our resources, and government appointed us as to manage the National Ventilator Project. So all our skill sets, put our heads together, and we designed a non-invasive, low-cost ventilator. Within 4 months, we had designed and manufactured 20,000 of them for our country. It goes to show that the skill sets that are required for data scientists, astronomers, they go across the board, whether it's banking, developing a solution to COVID, or whatever the case may be. These skill sets are not purely applicable to astronomy. So when governments like ours did in this project of building a radio telescope, we've shown now how these skills can be used and transferable to other national issues. We strive towards localization. This is growing capacity. An example of this is a small company in South Africa manufactured printed circuit boards, but they were being costed out of the international market. They were having to import instead of export. And so we came up with a collaboration with government where we helped fund them to grow in the way they needed to grow to become competitive. And now we have a situation where they're not importing, but they're exporting. So localizing can turn industries around like this. So innovation, this bridges the gap between invention and utility. I'm an ideas person. So you have these people who come up with wonderful ideas. They invent great stuff, but there's a big road between someone inventing something clever and actually getting it to market and people making use of it. And innovating is that road between having a good idea and making it useful. And so we translated research into utility, and we're quite continually doing this and able to show the benefit of doing it. So some of the technologies we've developed, Scarab, for some reason our scientists and our engineers love giving insect names and rodent names to our technologies. I don't know why. We have Ratty, we have Scarab, we have Roach.
Yes, got it.
Meerkats. So this is reconfigurable high performance computing, and this is because we needed energy efficiency, and a big challenge, as you may know, well I'm sure you know, with computing is cooling. So we've developed something that we call Iron Hive. It's a hermetically sealed high performance computer in mineral oil. So it takes away the need for having a big cooling facility. And we're designing these to be robust so that you can literally plug and play in rural areas. Some of the SKA dishes are planned to be remote outlying arrays. They will need compute. So this has an implication to Africa and to rural areas. You don't need to build a big data center. You can literally drop these things. They can stand alone. They just need a pipe into the ground, and they can run as a supercomputer. I won't go through all our technologies, but many of these, like I say, were developed out of necessity. So I manage the Africa program. I'll touch on the AVN program, which is our first step into Africa and involvement with radio astronomy in Africa. But there are so many other programs that are happening around Africa in the radio astronomy and data sphere. So we decided to encompass this in the Africa program, built on collaboration and partnerships with all of these groups, so that we're not duplicating efforts, duplicating expenditures, and that we're actually complementing one another. So of course, DARA, you all know, that's a big partner of ours. They're doing amazing things across Africa in terms of training, both in the data science field and radio astronomy. Doppler is the Portuguese version, so a big collaboration with Mozambique. Jumping Jive, and as I mentioned, many internships, bursaries and graduate programs. So the Africa program we're designing now around 3 pillars: human capital development, research and technology infrastructure, and funding, governance, and partnership. I can't emphasize partnership enough because funding is a challenge, but partnerships allow us to leapfrog ahead of where we may have been without those partnerships. So I think no one has spare money anymore. No one has spare resources. And so by collaborating, we're able to bridge those gaps and fill those gaps. So the AVN is the African VLBI network. VLBI is very long baseline interferometry. I had to practice that many times when I started. Essentially, in my simplistic understanding, the further you have dishes apart, the longer baselines you create, and the better resolution you have in space. So the longer the baselines between dishes, the better. So the first partner we worked with was Ghana, because that's our longest baseline. So you can see the countries there are Botswana, Ghana, Kenya, Madagascar, Mauritius, Mozambique, Namibia, and Zambia. In alphabetical order, not order of preference. So all 8 countries supported us in our bid to host the SDA, and for their support in the bid, we came up with this program to implement radio astronomy infrastructure in their countries. Ghana was the first, and they had an old telecoms dish, 30-meter dish, that we converted into a radio astronomy dish. It is now operational. Because of COVID, we still have a second engineering phase to complete. But it's performed VLBI both with the EBN, which is the European VLBI network, and with HOTRA in South Africa. The idea is to put these dishes in each of the other countries. But there is a challenge where Africa, each of these countries needs to supply fiber, electricity. We need to develop the skill sets for these countries. And so the program is not running forward fast enough in terms of infrastructure, but we're spending a lot of time on the big data training programs, the bursary programs, getting the human capital in place. Nobody wants a big shiny dish and their own people can't operate it, maintain it, and do the science on it. So it's become a big holistic program working to build the capacity and not just instrumentation. There are also challenges with operations and maintenance, and I'll come to this later. It's now not only a partnership within education and infrastructure and engineering, but a partnership with the space industry at large to help fund these sites. So this Ghanaian dish was inaugurated in 2017. And the program status, currently, aside from the human capital development, we're going to roll out a 2-dish interferometer to each country. So that's 2 3-meter dishes, which we'll be putting at university sites. And these dishes are used for training in single dish science, the associated data sciences, and in interferometry science. And we hope that by the time all the countries have their 2 dishes, that we can then do a VLBI training program and link all the countries together. There are a number of partnerships we've been exploring for Namibia. One is you guys are looking at the AMT. This is a millimeter array telescope. Millimeter telescope that's going to be implemented in Namibia. And we're looking at a partnership with them because of funding challenges that we can actually use the same dish for both sciences. So we could put 2 receivers on one dish and it can do the millimeter science and the VLBI science together. So we've had to come up with solutions and partnerships like this to move things forward. we'll have to see how that project goes. Our engineers are still busy trying to figure out that we can do both types of science with one dish. And of course, high performance computing, as I've said repeatedly now, it's the biggest part of radio astronomy. And so our Center for High Performance Computing within the Department of Science and Innovation in South Africa has been establishing high performance compute capabilities across our partner countries, either by implementing computer labs at universities or giving them high performance computers to be able to use and train on. And like I said, it's challenging. So we've given high performance computing to some of the universities across our partner countries. And some of those partners actually can't afford the electricity to run the computers. So the challenges are many, and we have to come up with unique solutions to implement this program. As I mentioned, the bursaries and our human capital developments and the importance of DARA. We hope that we'll be able to partner with the DARA team further in the implementation of these training telescopes, that they can run the training programs and maintenance and operation training. But that is still to come. And the Africa Colocation program. So this was born out of the challenge that I mentioned to you of operations and maintenance and resourcing of these sites. So we've run a pilot program in Ghana, and here we've partnered with industry and implemented a satellite receiving ground station on the site. So this ground station receives data from Earth observation satellites, and they pay a hosting fee to the Ghanaian site for hosting the dish. They contribute to electricity, fiber, they contribute to the cost of staff, because the same staff can manage the computer and operations and maintenance of both a radio astronomy dish and a ground station. And so now the funds coming in through this collaboration with the space industry is now contributing significantly towards the sustainability and operations of this site. I always say space science and technology because space science incorporates radio astronomy, and we have two types of ways that we interact with space. We're either on Earth looking up at space for the purposes of science, so this would be astronomy, and then we have the satellites in space looking back at Earth, and this is for science and industry. You can't draw money from an ATM without the satellite system that's up there. You can't check the weather. You can't fly in an aeroplane without navigation. All of this is reliant on satellites. And so remote sensing data and the analysis of space data is essential to the operating of our country, solving problems in climate, environments, agriculture, water management. I mean, the list goes on and on. We showed an example in Ghana where we took a satellite photo and we were able to identify 12 illegal gold mines that were happening within that image. And the illegal gold mining in Ghana costs them hundreds of millions of dollars every year. So satellite data can be used to solve national problems. And that requires data scientists. It's only the people who know how to work with data and computers. You guys are the ones that come up with solutions. You know, we had some young people in South Africa came up with an app where they use remote sensing data to look at agriculture. And so farmers can use this app on their phone, and they don't pay a big amount, but there's lots of farmers, so it's quite a lucrative business. And the app will notify the farmer, this tree is not getting enough water, that area has got insects, whatever the case may be. And they're able to have real-time monitoring of their agriculture to make the farming more efficient and saving money on losses. So I think the data scientists are key to our future in science, our future in discovery, and our future in space, and our future here on Earth, and sustainability on Earth. All we do with these big instruments is create the ability to collect data, but it's the data scientists, the computer scientists that turn that data into information. And like you said, it's a raw material, and data is a new raw material, but information is where the new power is at. And it takes data and you guys who process that data to create the information that is really valuable. everyone's talking about the fourth industrial revolution, but I actually listened to a conference that's now looking at the fifth industrial revolution. And this is now moving away from technology, but focusing on people. And people are the future. All of this is just technology, it's just instruments. Have an earthquake and use your telescope, use your computers, but it's people that will rebuild and people that make use of this and that can change things for the future. So that's why I say I like to use technology to improve lives, and collaboration is important. And by pulling together space science, space technology, and all of this together, you data scientists can solve our problems of tomorrow. So, any questions?
Thank you. Are there any questions? Anyone with any questions that you would like to ask? Or any clarification that you need? Are we scared? The room is full.
I normally get at least one question about the moon balls.
So, okay, maybe let me ask on behalf of the people. How can I get more information regarding the scholarship and the training program that are available?
So you can look at our website. It's sarao.ac.za, and DARA, of course, they know most of what we're doing. So if you're interacting with the DARA team, all our bursaries and programs are on our website, as well as the NRF website, the National Research Foundation. So that is nrf.ac.za as well. And you're welcome to ask me. I can always try to put you in touch with the right people. And yeah.
Yeah, I just wanted to know if you're aware that the site is actually for ANC or.
So currently the sites that you have in Namibia is the site, I can't actually give you the address. It's on a high mountain because we need low humidity. But currently you have the HES telescope there. So if you look up the HES telescope, it's on that site. That site already has infrastructure, electricity, everything it needs, so it would make sense. There are preferable sites on higher mountains, but it means building roads, and the infrastructure is a nightmare and very costly. So probably this will all be implemented at the HES site.
Okay, I'm sure there will many maybe are scared to actually speak out in front of everyone, and they will engage you during the debrief.
Yeah, I'll be here until lunchtime, so feel free if you want to. Okay.
Another round of applause for Kara. Thank you very much, Kara, for your presentation. I could not agree more. I think collaboration is key, and data science and data in general. We call it the new gold mine, but for us to get the gold, we need to dig, and we do the data science, and then we then derive our insights, and which is the information which we then need to inform policies or to improve sciences, or to find new ways or how we can make as you have said, our planet more and more sustainable. I don't think there were any questions on YouTube. Let me just quickly check. Yeah, do that. Yeah, no questions on YouTube as well. Okay. I'm sure that we'll all just engage during the tea break. Okay, moving forward, I think we'll then have another presentation by Mr. Charlton Peterson from Standard Bank. He's a data scientist and RPA developer at Standard Bank. And it's also good to see that some of our students, he was a NUST student, so he did his honors in applied statistics, and now he's a data scientist at at Standard Bank. This just shows that data science is not one dimension. It's a fusion of different disciplines, and it requires multidisciplinary view of looking at things. So, Dr. Peterson, can you join us up here? Oh, okay. I think, yeah, he notified me that he's going to join virtually. So, but before that, let's actually go on to the next presentation from MTC, where we have Ms. Fidelia and Ms. Ella to actually just guide us on the data science that they do at MTC. And the title of their talk is titled Data Science the MTC Way, or Data Science the MTC Experience.
Thank you for the warm welcome. I can see you all today. Just take a few seconds. Hello, thank you once again. So we are here to represent MTC. I am Fidelia Namopule, and this is Mrs. not Mr. Ella Shimi. She'll be presenting with me. We actually have two data scenarios today, so she'll be presenting the first one and I the second one. So actually, I'm as well a product of NUST. So just showed how NUST is pushing out the best there is out into the industry. And Ella is from UNAM, so top universities in Namibia. So yeah. So I'm a data engineer and Ella is a data scientist. So I'm just going to introduce our data analytic team. It's small, but it's mighty. So we have some of my colleagues here seated. We have Latoya. Latoya is a product of the University of Western Cape. And Mrs. Ella from UNAM. We have Yalo from IUM. Carlos Acosta, he's participating in the hackathon today. And he's been from NUST. Yeah. So I very have an understanding of big data in terms of what NUST offers, as we've interacted before in the past. In the past, we've actually provided data sets to students in order for them to analyze. We are forever engaging with NUST just to help when we can and to make sure that the students have industry experiences. So currently, I'm aware that NUST offers a certificate in big data technologies, which actually just helps equip students to be able to find employment in public and private sectors. And as well, I being from NUST, I didn't take this certificate, but within the computer science field of study, specifically the software development strength, there are a lot of courses that are offered that actually helped me build my data analytics foundations, such as data structures and algorithms, data fundamentals, and others. So hopefully one day in the future we'll have a data science strength as well. I'm just hinting on this, but yeah. So yeah, so these fundamentals can help a student start their career in data science, as I did. So yeah. So as well as at MTC, when one goes to MTC, MTC helps its employees fund for their courses in which they are interested in. So for example, we are currently taking the Google Data Analytics Certificate through an online course called Coursera. So this one just takes about 6 months and it's equivalent to a 3-year degree. So there are many options out there in order for one to build their data analytic career. We also have Latoya, who has taken data analytics at the University of Cape Town, business and system analytics through Stellenbosch. So if you are really passionate about what you want, where you want to get within MTC can help you fund for your studies and courses. So yeah, MTC as well offers internship opportunities to students, which is how I got into MTC in the first place. It was just a 3-month internship. You try to prove that you are capable in what you are assigned, and then from then now I've been there for almost 3 years. So yeah, in the past 3 years, MTC has employed 8 graduates just in its IT development department. So this just shows that MTC is willing to take on students with or without much experience and be able to like turn them into experienced people. Yeah, data miners, for example. So we also employ from other institutions, so we are not just biased. So from UNA we have Elashimi, from IUM we have Yalo, and from NUST as well we have Alon Sakosa. So yeah, I'm just going to hand over to Mrs. Elashimi on the first case study on how we use data science in revenue assurance. So yeah.
Thank you, Fidelia. Good morning, everybody. My name is Elashimi, as mentioned by Fidelia. Today I'm going to talk about revenue assurance in MTC and how we use data science for revenue assurance. So when we talk about revenue assurance, we are simply ensuring that all the transactions and all the events have been billed correctly. And by billed correctly, I mean no loss of revenue. So as you all know, MTC is a big organization, and with that comes complex processes, and these processes may sometimes result into revenue being lost. Okay, so in cases like system failure or human errors, all of this could lead to revenue loss, but with the correct analysis or with data analysis, we can make sure that we avoid the process of revenue loss. There are also situations where systems will be upgraded, technologies will be upgraded, and with all this, it also may result to revenue loss, but with data analysis, we can avoid the process of losing assurance. And we have an example here of how we use data science. In this example, it's for a billing process. A billing process takes place every month. And in this example, it's for discount rates. So in the yellow section there, the highlighted column, it shows the correct discount. And then the column right next to it is the discount given. So before data analysis would come into play, the column for discount given was the actual discount that we're going to bill to our customers. But using the correct tools, we calculated the correct discount using data analysis processes, and then we were able to give out the correct discount to customers. So this just shows that data analysis or data science is very important in every organization to make sure that we give out the best they're based in quality results, or yeah, in this case, billing the customers correctly. So yeah, all in all, this is one of the examples of how we use data science to make sure that we don't have any issues when it comes to revenue, and yeah, I hope you guys get what I'm trying to explain to you. But thank you very much.
Thank you, Ella. Yeah, I think sometimes we as data analysts, we kind of like have a battle. Like when it comes to presentations like this, you've signed NDAs, you just can't tell everything. So there's we know so much, but there's so little we can share with you guys, but it's part of the organization's policies. So yeah. Anyways, I'm going to move on to the second case study, which is understanding customer behavior. So in terms of customer behavior, we use data science to understand the change in the behaviors of customers, so that we are not caught off guard and we know what is expected when something happens, like, oh, this is normal, we expect this during this time of the year, like that. And like with the world forever changing, like currently life is expensive, so just like how things are changing, we also expect how customers behave after our products change. So yeah. So for the first example, I'm going to talk about like the activations and terminations of customers. So are we gaining more customers or are we losing them? So obviously when we are gaining customers, we are obviously happy. But in the terms of like when we are losing customers, it's like we still need to, like, maybe we should not panic just yet. Are they like terminating maybe they are 4G subscriptions and they are changing to a new product that we just pushed out there, like for example Spectra. So yes, Spectra is okay. We as MTC ambassadors, although we work in different departments, we are always marketing people. So I recommend that you go for Spectra. It's way faster and it will be good on your pockets. So yes, yeah. So yeah, as I said earlier, like right now during the pandemic, and especially now in the times of inflation, everything is expensive. So we need to understand, like, at the end of the day, when someone sets out their budget, just how much are they willing to spend on credit, on data, like that, like with the bread and fuel prices increasing, how much are they still willing to pay for our products? When you have when it's almost at the end of the month, will you buy bread or will you buy credit? That's our real competitors. But I think it would be wise to buy credit, because with credit, you can make connection, you can make more money. Eh? So yeah, so those are our real competitors, although there are other telecommunications, but that's what we look at. And actually in the younger generation, our competition is Namibia being Namibia, is there. Will someone buy credit or will they go spend their last $20 on their So we need to understand all these things. So yeah. So we also look at how customers are using their data. So someone bought an away. So at the end of the away, when the away terminates, did the away end maybe on the third day? Does this mean that we are having bundles that are not having enough data? So we need to understand that so that we create personalized products for those customers. And if they, at the end of the away, maybe there's too much data, and then we can also adjust like that. So we also have to understand that during different periods of the year, we expect customers to behave differently. So during the festive seasons, we expect maybe usage to be lower because maybe our postpaid users, which are like usually companies, their employees are on holidays, they're in the village. So there isn't much data usage. So it's normal. So but when the year resumes, then yeah, back to business. So yeah, I could just think of other examples that I've not placed on this presentation. But we usually have like maybe customers like their network is not fine at a certain regions, certain parts of the country. So we also analyze such data to see like just where can we place a new cell tower, and we just can randomly choose. Oh, here it looks like there isn't many cell towers, but maybe it's because it's not really there. So we need to understand our customers to see which customers are complaining. We look. As well, look at social media comments, how customers are reacting to things, so that because our customers they are a source of income, so we need to please them at all costs. So yeah. So maybe you're wondering how we do all this. So I'm just going to run you through the technologies that we use. So we use programming languages like Scala and Python, but we are not limited to them. If we say something out there is better, we will change to it. We are not stuck up on things. So, but currently, we use Scala and Python to consume data. So, okay, let me just, in general, like every second right now, data is being produced. So we don't wait for data to pile up. So currently when the data is coming in, we should be consuming it, because like this time, like if you let it pile up, then you'll not be able to consume it. So with these languages, we are able to consume data in real time and then clean it, put it on our database, analyze it, and just have real-time graphs updating. So yeah, so maybe within 5 minutes from the input point from the cell towers and all that, within 5 minutes, we have graphs already, so that we see like what is happening, so that we can also see like this. So you said like, is something fine? Yeah, like that. So yeah. And also the data processing technologies, once this data is consumed, my number one to go to is actually Spark, which is a very powerful technology. Yeah, but sometimes you can just analyze a small file. You can use things like such as pandas and spreadsheets, but that's for a low scale. But if we are processing like 5 million records within one day, within half a day, so you need fast technology which can do this within minutes. So yeah. And then after we processing our data and like producing the results, we need to visualize this. So to our stakeholders, to our managers, because they don't want to see funny numbers, so you need to present it to them all. So in this case, we use technologies such as Tableau and Grafana. So with these different technologies, this is just one of the setups that process the data. So with Scala, which is processing the data from the cell towers, we have this we call them what? Consumers, because they're consuming data. We have these consumers deployed in Docker, and then which is contained within Kubernetes cluster. And then from here, our preferred database currently is Cassandra, which is a non-SQL database. But there are so many things out there, so we are just not restricted to this. So once the data is in our database, we use the Spark cluster to process the data and then visualize on Grafana. But we do have other sources of data. So many, it's like, yeah, it can be overwhelming at times, but yeah, we do manage. So, so yeah, and that is it. Thank you all. Before I finish, yeah. Currently, we do have 2.5 million active subscribers, and I said earlier, every second data is coming in. So you can just imagine how much data we have, and we need to make sure like we are analyzing everything every second. So Yeah, just so that we give the best experience to our customers. Thank you.
Thank you very much. Are there questions?
Don't be shy.
Are there any? Oh, there's a question.
That's what you know the
The term of we actually have the IT development, and within the IT development we have different subsets, which one of them are the data analytic team, and then we have the web development team that includes mobile applications and all that. And then we actually have a project manager within our there is Mr. Adolf Nafenova, and also Mrs. Bonita. She's a bit late. But yeah, those are the keepers in check and make sure that everything is done on time. So, yeah.
I have a question. How long did it take up to, because a lot of companies, they often go to buy BI systems, and as opposed to them coming up with their own. How long did it take you set up your own infrastructure? Because I see you're using your Kafka, your Spark, for streaming, then you stream the data from the different sources and then bring it in Cassandra.
Yeah, let me actually tell a story on that. Most companies do so, and we did do so like initially, and you cannot just cut off a system entirely. Even those systems that we bought for data analytics, they still support us. But it was with the initiation from Prof. Panam, who will be here in a few days. So I came with an internship. It was just a small analytic problem, and then from there we built from there. So he's the one who gave us this whole architecture you are seeing here. So he recommended what software to use, the Kubernetes, the Docker. He's really good. So he's a lecturer of NUST. And then, we actually started off as students. We have been guided by him, but we soon took over, and he just advises us here and then. Any more questions? All right, thank you. You can engage with us later if you feel like it. All right.
Just bear with us a minute. We're just trying to get Charlton Peterson on. Then just a minute or two. Then they can then tell us how they do robotics process automation standardly. Okay, thank you very much, Fidelia and Ella, for that wonderful presentation of actually taking us through how you use data science at MTC. And I think a lot of people in the room are kind of inspired, and then they can also try to do the same in their own organization. So, Desiree. So, we really appreciate you guys for coming today and really just engaging us on this and sharing your experience. Of course, our DVC has another engagement, and so he has to leave us. Before he leaves us, we just ask our acting executive team to just do a vote of thanks, and then we'll then continue with the next presentation. And just to just a simple clarification that we appreciate Fidelia and Ella. Your gifts we will actually give them during the course of the week, because we are still waiting for the vendor to get our branded items that we can give as token of appreciation. But because Carla is actually leaving tomorrow, we just wanted to give her something as a token of appreciation for coming here.
Thank you, Lamek. Oh, sorry. Thank you, Director of Ceremonies. He's the boss today, so I should accord him the respect that he deserves. So, good morning, participants. Good morning to our esteemed speakers and the organizers who are making sure that we have this event running. I would like to start by reflecting on the two ladies from MTC's presentation, Ella and Fidelia. You brilliantly presented on the opportunities that exist for the alumni from our two universities within the industry space, which is very commendable. And I would like to invite you to come and do your masters. We have a Master of Data Science at NUST running since the beginning of the year. And I believe it can enhance your skills and make your jobs more doable and more practical. We are in the process of working on a bachelor's to accommodate the lower stream. So we start with an honors, then we'll move back to the beginning. So with that being said, my responsibility is to come and thank you all for your participation in this program. First of all, I would like to extend a heartfelt thank you to the funders of this program, the UK Institute of Innovation, as well as the South African organizations, the National Research and Innovation Fund, as well as Sarao, who are the active participants in enabling the SKA project, as well as the capacitation of the region on data science skills. Furthermore, I would like to thank Ms. Ella Shimi, our data scientist, for sharing your expertise and how you have applied your intel in manning the data at MTC and giving us a glimpse of what you're doing with our subscriptions and with us as your customers. Of course, you have about 2.5 million customers because everyone subscribes to MTC, me being one of those subscribers. So when you were showing that screenshot of someone's account, I was scrutinizing it and thinking, you may know the client that's being displayed on the screen there. Thank you so much. And to Ms. Fidelia, Popile, I hope I did it well. The Popile, thank you so much for your work that you're doing and for inspiring fellow students that the sky is the limit. With the skills that we give you, they might not be speaking to data science directly, but you can actually harness them and use them to propel your new discoveries and your journeys. By the way, when you come to NUST, we don't give you your career. We give you the skills and the vision to maneuver into your own space as you discover yourself. So I'm glad that the skills that we gave you, which could have been a database administrator, a database developer, you chose to exploit them and choose them to become a data scientist. May you continue to explore those avenues and also inspire more data scientists to come on board. To Mr. Charlton, who is here to speak to us, we are looking forward to hearing your speech, and we thank you for taking your time to come and share your experiences from Standard Bank, Namibia. And we appreciate your partnership with the university. Yesterday, we celebrated your CEO sharing during the award ceremony and the commitment to the development of the education system as well as the skills for the nation. So we really appreciate that and we look forward to hearing from you. To our esteemed speaker, Dr. Kala Shape, thank you so much for taking time to fly in. I know the fatigue, and I know that is a moving lab. So the experiments are happening and the coordination is happening while you are here. But we really treasure the time that you took to be here and to be actively on the ground and participating in our school. May you continue enabling such schools, not only in Namibia, but across the 8 countries. I see there's a 9th one that is now Kenya, so that we also grow the skills in our continent and also embrace the other neighboring countries who are not yet participating, because I believe we can grow together and we can upskill our nations through that initiative. Keep on the good work that you're doing. To our acting DVC, thank you so much for taking time. Of course, we know you wouldn't have missed it for anything in the world. This being your passion, may you continue to support and to give us the vision to innovate as a university. I saw when Carla was speaking, you were actually glittering with enthusiasm because she was speaking to your partnership portfolio, to your innovation portfolio, and to the localization on making sure that the research that we are doing within the university is actually turned into some socio-economic benefits. So may you continue doing the good work and giving the support that you are according us. To our partners, industry partners who are championing the day-to-day, we really appreciate you. We hope that based from this school, we are going to have more projects that we are going to work on together. And I know I see the MTC is well represented today, and they are busy revamping their space that they've claimed in this space and branding it so that it can as blue as it can be. Thank you for that support. I hope, Juanita, you're going to recruit new talent while they are here. It's so encouraging to see you coming in person. So thank you so much. And for those partners that I did not mention by name, it's not that I'm excluding you, but it's just that I didn't get the opportunity to know who else is in the room. We appreciate all of you. Our key reason why we are here, the participants of the school. Thank you for coming and for soldiering on. I'm told that yesterday you were given some homeworks that were excruciating, and you still made it today. You showed up. Thank you for showing up, and I know you're going to show up tomorrow, and you're going to show up on Thursday until you get your certificates. Keep on keeping on, and I believe the solutions that we promised are still coming. So I'm still looking forward to those solutions. Thank you all, ladies and gentlemen. Organizers, keep on keeping on. The journey is still on. Master of Ceremony, before I go to the MC, DVC, before you leave, I need you to come and do the honors of handing over our gifts to Dr. Kala Shake. And Doctor, can you make your way to the podium? Thank you. Providing evidence. I like this.
This is in 2018. Oh, thank you.
Thank you so much.
Okay, thank you so much. I know it's we've been here for about 2 hours while we're actually setting out the presentation from Standard Bank. To be nice, to just allow the blood to flow. So just maybe stand up where you are, stand up and just allow the blood to flow, to circulate properly in your body. And then, Charlton, can you hear us? Charlton, can you hear us?
Morning, hi, I can hear you.
Yeah, okay. Okay, Jonathan, are you there? We can hear you. Can you share your screen, please?
I will do so.
Okay, great. Can you just say something so that we can see if we can hear you?
Can you guys hear me now? Am I audible?
You are audible. Just speak a little bit louder, but you are audible.
Okay, yeah, I'll do so.
You just share your screen so that they can be able to follow you. And maybe just a brief introduction. Charlton is one of our former students who is working at Standard Bank, Namibia, and he is a data scientist and robotics automation, robotics process automation developer. So he's then going to share us his experience and how they use data science at Standard Bank. Charlton, the floor is yours.
Is my screen visible?
It's still coming. Yeah, it's visible now. You can go on.
I know if you can hear me clearly, if the audio is fine.
Yes, we can hear you. Just speak a little bit louder. I think it should be fine. We can start, Charlton.
Oh, okay. Okay, my computer is frozen. Apologies. Let me just get started itself. So as Meg has introduced me, my name is Charlton Peterson, and I am a scientist at Standard Bank Namibia. I am currently under the Enterprise Data Office team, where data analysis and data analytics. Data scientist, my duties consist of
Charlton, I think maybe try switching off your camera because the network a little bit. And then give it a try again. Okay. Can you maybe try then giving your presentation again?
Let me just rejoin.
We apologize for the technical glitch. Everything has been going so well, and then this. So just shows that, you know, whenever you're having a technical interaction or a technical glitch will always be there. I don't know why. Is it by coincidence or just meant to happen? Yeah, I agree, it's by design, so it's inherent. Charlton, are you there? We apologize for that. Let's just try to see if we can quickly get him on. If not, we'll improvise. Okay, it's not good to just be here waiting. So what we then gonna do is quickly break for tea break, and then we'll then continue afterwards. Does that sound better? Okay, let's then quickly break for tea break, and then we shall then come back in 25 minutes. So for those who are joining us on YouTube, we will actually break and then we will then resume in 25 minutes. Captain, are you there?
Lamek, hi, can you hear me now?
Yeah, we can hear you now. So we are quickly going to break for tea break. Let's sort out, let's see if we can get the technical glitch. Just so
Okay,
that
so
we
I'm
don't
assuming
have-
that.
Yeah, let's just sort out the technical glitch so that when they come back, in 20 minutes, we are sorted.
Yeah, but you can hear me clearly now, or am I still a little bit soft?
I can hear you clearly now. Let me just see. Like, the audio, because I want your sound to come through the. Okay, say something.
How about now?
Jonathan?
Can you hear me?
I
Yes.
can hear you.
Is it loud and clear or?
No, it's nice, loud, and clear.
Okay, that's good. Okay, because I don't want to be here in shouting and disturbing people.
Yeah, no, it's fine.
Okay, cool.
Okay, can you just test your presentations? If it's,
Okay, let me just. Can you see my presentation? Can you see my screen?
you can see your screen.
The slides moving smoothly.
Yeah, now the slides are moving smoothly.
Okay, that's good.
Okay, good. So basically, just put it on the main one and then we'll resume after 20 minutes.
After 20 minutes, okay.
Yeah, after 20 minutes.
Okay, so yeah, okay, so I'll just go on mute and just leave it as it is because it seems to be working fine now. Yeah.
Charlton, are you there?
Hi, Lamek. Yes, I'm here.
Okay, good. We'll be resuming shortly after a minute. Just be ready.
All right. Yeah, noted. Thanks.
Okay, good. Charlton, you can actually get started with your presentation.
Okay. So good morning, everyone. So let's try this again. Hopefully, we will not experience any technical glitches going forward. So my name is Charlton Peterson. There was a printing mistake on the flyer, so it's not Peter. So just keep that in mind. So I am a data scientist at Standard Bank Namibia, working under the Enterprise Data Office team, which looks at data analysis and analytics for business. So my main focus as the data scientist is the deployment and development of data science models to connect business questions with quantitative answers, with the objective of increasing business efficiency and also at the same time trying to achieve strategic goals set by the Data Office, Standard Bank Group, and Standard Bank Namibia. So today I'll be talking to you about data science in the industry, with the focus on the financial services, and then I'll also give you a brief overview of what data science looks like from a Standard Bank Namibia perspective. So I'd just like to give a quick disclaimer. I am representing Standard Bank Namibia. So there's just a few disclaimers. So just take everything I say or share with a pinch of salt. So here we have the outline for my presentation. I'll try to be quick and concise. I'll give you a brief overview of data science in my introduction, and then we will look at data science in the financial services industry, and then also look at a few applications, and then also, as I mentioned earlier, provide a couple of use cases of data science in Standard Bank Namibia, as we try and execute against very demanding business requirements. So you might have heard this over the last day and a half. So data science is relatively new. So the term data science was coined in 2008 by scientists working at Facebook and LinkedIn. So it's a interdisciplinary field, which is a blend of statistics, computer science, math, engineering, and domain knowledge, which is like really important when it comes to data science. So even though data science has been around for the last 14 years, we've only recently begun to catch up, and that is to the rest of the world who has been using data science to their advantage. So I would like to say that the building blocks of any successful industry is education and infrastructure, right? And then just to give you also a brief background, is my first encounter with any data science related activity or that sits outside of it being online and being outside of the African continent. My first experience was the Big Data Hackathon that was hosted by DARA back in 2019. So this was an insightful experience, and I would like to think this is where my journey as a data scientist started. And now looking back a couple of years later, we are growing as a community in terms of data science, because now we have a master's in data science program offered by the School of Computer Science here at NUST. And at the same time, we have events like this that just strengthens the foundation of data science in Namibia and Africa as a whole. So there is a lot of short courses and data science programs offered all over the continent, which wasn't the case a few years back. And at the same time, we have useful platforms like Zindi, which host hackathons pertaining to solving African problems. So we have grown and we are continuing to grow in terms of data science, right? So now looking at data science in the financial services industry, right? So data has always been at the heart of finance. So in fact, data science and finance go hand in hand. So finance was using data science long before the term was even coined. So data scientists are crucial in almost every industry. But in finance, it's one where they are especially important, right? The financial industry has used big data to transform everything from how the stock market works to detecting fraud and even improving customer experience, which is like a big objective for your financial services industry. So rather than simply collecting, mining, and making sense of data like your normal data analyst would do, financial data scientists are industry experts with specialists in depth domain knowledge. And just keep the emphasis on domain knowledge, which is really, really important. Following that, let's look at some application of data science in finance. And in this case, these applications are mainly in your retail banks, such as Standard Bank Namibia, FNB, Bank Windhoek, and the likes. And then you also have your insurance providers like Old Mutual and Sanlam, and also making use of these use cases. So when it comes to data science in the financial services industry, it does not have to be complicated. So we are not your academic researchers. We try to keep things as simple as possible, as we try to execute and meet business demands, right? So we try not to overcomplicate things, and we just try to keep it as simple as possible, because most of our problems come from business and we have to answer to them. So we try to keep it simple. A very common application is fraud detection or the prevention thereof. So just to give you a bit of a background, so the traditional method for fraud detection was mainly rule-based systems. In today's industry, it is still fairly still used. So this is where you have a fraud analyst that would build a rule-based system that consists of about 300 or more rules against which transactions are checked before it's like flagged as fraudulent or non-fraudulent. The biggest con of this approach is it's a little bit slower, not as slow as you might think. So when you compare to something like machine learning, it is slow because machine learning tends to be quicker. And the other con of this is that it tends to result in a high number of false positives. So this is where you have a transaction flagged as fraudulent, but it is not. And as a result, when you're trying to block a large number of legitimate customer transactions, it then in turn impacts customer satisfaction if your system does not get it right. And this is a big no-no, especially if you're in the customer service provider. Next thing is you hear marketing has called a meeting because a client is unsatisfied and the business is getting dragged onto it. And this is because their need was not met. And because of this high false positive inconsistencies in rule-based systems, they tend to be inferior to machine learning driven ones. But they are still the go-to choice for fraud detection in today's day and age in many financial services. And the main reason for this is because they cost less, and setting up these systems, it's much quicker to just get a third party to provide you with the solutions and let them do all the heavy lifting. But we do, however, have some leading financial institutions. These are institutions that have the resources to back big data machine learning projects. So in this case, it's your MasterCard and PayPal that employ machine learning to combat fraud. And the main reason for this is that, like I've mentioned earlier, is that your machine learning systems are faster, more accurate, and it also allows for real-time fraud detection. And by now you should have then picked up that your fraud detection is a classic classification machine learning problem, right? So this is just classifying your transaction as fraud or non-fraud. And the most common supervised machine learning approach for this is your random forest, which is an example of your data decision trees. And then you have your SVMs, which is your support vector machines. Then the industry also employs k-nearest neighbors and your neural networks. The only downside of your machine learning approaches is that it lacks interpretability. So if business were to ask you why your model has picked this transaction up as fraud, it would be difficult to explain to them why the machine then decided to flag that as a fraud. And the other downside is it requires a lot of data to build an accurate model. But this is not really an issue in the financial services industry because we produce about millions and millions of rows of data per day. The next application is your customer analytics. So this is a bit of a broad one. So financial institutions have made customer experience and personalization a top priority. And thanks to data science, they can use real-time analytics to gain insight into customer behavior and make better strategic business decision, or at the same time, they can offer consumers recommendations based on their banking and investing preferences. And then at the same time, depending on the problem you're trying to solve in terms of customer analytics, you would then use different machine learning techniques and approaches. Some of these we do make use here at Standard Bank Namibia. These are your basic machine learning approaches. The first one there is your behavioral or your customer segmentation. So this is the process of categorizing customers into groups based on shared characteristics, so that business can market to each group effectively and efficiently. And when tackling a segmentation problem, the answer is usually your unsupervised machine learning models. And cause what you're trying to do initially is just clustering. The next one, which is your next best action or the next best offer model, which is a form of predictive analytics that helps your marketers and organizations to better judge customer product affinity or customer product holding, and then also get insights on their transactional behavior, and then guide marketing efforts towards connecting customers with a close. To guide marketing efforts in terms of connecting customers to close a deal. So this is just segmenting customers based on the different product holding that they have and their transactional behavior, and then trying to see what you can offer someone that has a product that falls within that category. What else can you then offer them based on what similar characteristics they share with their peers that fall within the same cluster or the same segmentation. And then finally, the next use case, which is your customer retention. So this speaks to customer churn. So business always tries to be ahead in terms of being able to predict when a customer will end their relationship with a business. And this is then a big factor in determining the revenue of a business. So we always try to try to pick up on transactional behavior or indicators that the customer is about to churn. And if we then flag that this customer is about to churn, we then bring this to business and say, hey, look at this customer is about to churn. What can we do about that to prevent this from happening? At the same time, with this, we need to know also which of our customers are loyal. And we also need to know the factors that affect, or we try to pick up the factors that affect these decisions from a customer perspective. So we try to retain the most profitable clients, so that we can be able to achieve the best strategies for business. The next applications that we have, they're not going to go too much into detail with, is that are worth mentioning is artificial intelligence. So this mainly speaks to the field of NLP, which is natural language processing, which then allows for business to automate customer service through voice response and your chatbots. This is then where you have a chatbot that's able to interact with the customer, that have simple queries where you don't necessarily need a person to answer this. The next application there is risk analytics. This is also very, very important as business tries to avoid risk at all costs. So this is using predictive modeling, forecasting and scenario analysis to manage portfolio risk. So this is then your credit and market risk exposures, and also the valuations can be then simulated more accurately, thus then helping us banks, us the retail banks and financial firms to proactively monitor risk across the organization. At the same time, this then also allow us to be compliant. The next one, which is quite interesting, is your algorithmic trading. So this is more related to your stock markets and to your stock market traders. So the machine learning in trading is another excellent example of how effective the application of data science in the finance industry can be. So this is a machine learning based solutions and models that allow trading companies to make better decisions by closely monitoring trade results and news in real time to try and detect patterns that enable stock prices to go up and down. A good example of this could be the monitoring of Elon Musk's tweet. So what was happening last year is that whenever Elon Musk tweet, the cryptocurrency Dogecoin would normally pick up, right? So if you have a system, machine learning model in place that's able to monitor tweets, you are then able to sort of pick up on this, and then this then enables you to detect the patterns and then sort of predict if the stock price is going to go up or down. And then finally, we have your real-time analytics. This then is the application of institutions where we are able to track transactions, your credit scores, and your financial attributes without any issue of latency. This then allows us for real-time monitoring of transactional data, and then this then just adds on to us being able to predict customer churn, and then also pick up transactional behavior or customer transactional behavior. Finally, so in conclusion, I'd just like to say that industries are very eager to use data science to extract more value from the information they have gathered, right? And many of the game-changing and disruptive innovators based on data science, right? The main aim is to try and improve people's quality of life, whilst also in the process of increasing the efficiency and processes of services. So if we then concentrate on teaching and practicing data science in an interdisciplinary collaborations in cases such as this with your academic and industrial and government partners, we then are able to achieve results which will then lead us to be able to design, test, validate, and scale up locally developed future-proof solutions that will in turn aid services to meet Namibia's challenges and business opportunity. So that brings me to the end of my presentation. I'd like to thank the organizers of this event, in particular NAMEC, for this opportunity. Yeah, so thank you very much. That's the end of my presentation.
Okay, thank you very much, Charlton, for your presentation. A round of applause for him, please. I think he really highlighted some of the important stuff there. And the fact that I like what you said, that the financial sector has always been data-driven. And the example that you made on Elon Musk, that it was brilliant because some of us have invested in crypto and we were always looking at what Elon says. And now with the markets, we are suffering because of some of the things that Elon started saying towards the end of last year. Because if you look at it, last year, around September, one Bitcoin was about 60,000 US dollars. So, and it didn't cross 60,000 US dollars mark. And we thought that this was gonna be sustained for some time. And everyone was actually waiting for the cryptos to reach 100,000, one Bitcoin to be equivalent to 100,000 US dollars. And then Elon Musk said something about, you know, how Bitcoin and the cryptos, how they are not so good for the environment because they use so much energy. And we just saw a whole decline of the whole crypto market. And it was just not one crypto, it was pretty much all the other cryptos. And yeah, are there any questions?
Yeah.
Are there any questions? Let's just see if there are questions in the room. No questions? Okay, there is one from.
Can you? Okay. I don't know or whether you just spoke in general, but you talked about algorithmic trading or something. Do you guys started by actually doubling that? We have a general understanding that I don't know much about financial markets and like banks use our money to trade. You guys use our money to trade. What do you do?
Interesting one.
I'm sorry, can you repeat that question? The last part?
The question is, when she was asking about algorithmic trading and whether you guys use our money to trade.
Of course, right? So the objective is to make use of money, to make money. So yeah, definitely we do make use of your money.
Okay.
Please don't ask questions that will get me in trouble.
Okay. We'll try our means to make sure they don't.
Is it afternoon?
Yes.
Yeah, good afternoon. So how big is your team in Standard in terms of deal with data science?
So we have a fairly small team. Currently, I'm the only data scientist in the team, but we have other data analysts. We have a data engineer. So I'd like to say our team is about a maximum of or minimum of 6 people. Yeah.
Okay.
Is there any particular reason for that question? Is someone looking for a job opportunity or what's happening?
No, it's just, I guess, a benchmarking question because the person who asked this adoption is in charge of the data science team at MTC. So that's benchmarking, I guess. Or
yeah.
Oh, you're involved in setting up their section. Okay, great. Yeah. Okay, great. Okay, thank you very much, Charlton. We'll keep in touch. It was really nice hearing from you. And for those that have joined us through YouTube, we now going to end the stream because we then now going to focus on what we are here for, which is to hack the data and see some of what the teams will come up with during the hackathon. And on Friday afternoon, we'll actually live stream the presentations so that you can then see what the teams have come up with. And yeah, looking forward. And thank you all for joining us through the NUST YouTube channel. And we'll keep you up to date on the social media on how the hackathon is going.
All right, thank you very much, Lemek, and good luck to everyone with the hackathon. And just one last point, remember, Google is your friend. So once you guys tackle your problems, just remember Google is always there. That's how you grow. Yeah. Thank you.
Exactly.